Turning off the lights for me, please, and thank you. All right. So quadratic functions, you've done quadratic, whether or not you realized it. Remember factoring in grade 10? If you were to graph those things, those were all quadratic. They all look like this, like either it looked like this or like that. If you were to graph that, it's a parabola, we call it. Okay. So a linear function has the equation y equals ax plus b. You probably learned that this was m, right? mx plus b. We're going to change that, and you'll see why. A is what we call the leading coefficient. Like that first number in front of the variable is the leading coefficient. Make sure you know what this is. Think of coefficient as a number. Okay, that's just a fancy term for a number. Leading, obviously, it's the one that's at the front, but don't think it's always going to be at the front. And the constant b is the y-intercept. I don't know if you remember that. It produces a straight line. Since the highest power of x is 1, okay, the power of x is 1 right now, the equation has a degree of 1. Y equals ax plus b can also be written as this, where m is the slope and the constant b is the y-intercept, right? So this is the y-intercept, that's your slope, rise over run. We'll do that later, okay? A quadratic function has the equation. Look how it changes. It used to be just x and a number. Now you've got x squared. And all of a sudden a is in front of the x squared. Why? Because we always care about the highest exponent, okay? The highest exponent of x. That's where the leading coefficient is. All right. A is the leading coefficient. Sorry. Sorry, front row. I'm going to cough here. This takes me back to the bad days. Okay, A is the leading coefficient, and the constant c back here is the y-intercept still. It produces what we call a parabola. Since the highest power of x is 2, the equation has a degree of 2. And this is true. A quadratic function will always produce a parabola. And by parabola, I mean, right, the graph will either go up or down. State whether the graph of the following is a constant, linear, quadratic, or not applicable. Out of all 6, which ones are quadratic? This one? We're just going to go quadratic. Which other one? This one, right? Okay, quad. What about this one? Sorry. No. This one isn't, right? Because I did this on purpose because it's sideways. This is none. If you take pre-cal, grade 11, 12, you may encounter this, but we don't talk about that, right? What about this one? It sort of looks like a quadratic, but does it tell you that it's going back up here? It doesn't. So this is also none. These two, linear. Except for this one, this one kind of fits the linear category, but look at, if it's a straight line like this, horizontal, it's a constant. And if this, right now, I just want you to focus on quadratic, okay? That you recognize a quadratic function. Okay, let's keep going here. So all of these have a degree. Let's do that first. The degree here is 1. The degree of this, there's nothing there, so it's 0. The degree of this one, yeah, 2, 3. That's called a cubic. We'll do that next year. 1 over x, it doesn't really have one. I don't know if you remember when x is down here, this is saying that the exponent is technically -1. But I'm not going to go there because that's just going to give you nightmares, right? Remember simplifying expressions like that? We're not doing that here. This one, this one, no. This one would be -1. If you want to, if you really need to have that filled in. Sure. This one? You think it's 1, right? But if you were to, remember foiling this out, you get an x squared out of that one. So here's just a little, can you foil that out? I need to drink water again. Do you remember how to do that? Okay, so you go x times x is x squared, x times 3 is 3x, then you go over to the second one, -5 times x is -5x, -5 times 3 is -15. What do you do at that point? You combine like terms, like the x's here. X squared minus 2x minus 15. We can stop there because you can see, look at that f of x. I hope it doesn't scare you. It's the same thing as saying y is equal to, okay? It's just in a different format. But can you see now that there's an x squared there, right? The last step is what you want to do is take the 6 and multiply it out. So it's 6x squared minus 12x minus 90. Okay, right now, all I want you to know is when you have two brackets and each of them has an x in there, it's going to be x squared, right? You're going to get an x squared term out of that one. And so therefore, the degree of that thing will be 2. So which one of all of these will get you a parabola? This one and this one, right? Okay. So type of function would be linear. If it's 1, it gets a linear. If it's 0, it's a constant. Quadratic. 3 is cubic. We're not going to put anything here, but we have another quadratic here. Let's put none here for now. What's the leading coefficient for this one? It's 1. It's whatever is in front of x. So a is equal to 1 here. What about this one? It's not applicable. There is no variable, right? So we don't have a leading coefficient. This one? -3. It's wherever x squared is, you look in front of it, a is equal to -3. What about this one? 1. We'll just skip this one here. And this one? You gotta, yes, 6. Yeah, 6 is the leading coefficient. We're just going to go NA here. Then let's go to the first one. What's the constant here? The constant is the number that's by itself without a variable, so it's 7. This would be 15. This would be -5. This would be 0. Okay, technically there's a 0 at the end. The last one here, you had to do the foiling, right? -90. We'll just go NA for this whole thing. All right? Because you're not going to see that. You don't have to worry about it. But leading coefficient, constant. These two are going to be very helpful when we graph. Okay? So that's why I want you to know where they are. Let's go. Keep going. So, there are 3 forms of the quadratic, of a quadratic. The general is the one we're going to use most often. So in general, we go plus, 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 but it could be that there's a negative. Okay, so just so you know, this is just what it kind of looks like. And this one will give us, it gives us the y-intercept. Okay, that's what this one gives us without calculating anything. Okay, it gives us the y-intercept right away. The y-intercept is going to be 0c. Do you remember what the y-intercept is? It's where the line crosses the y-axis, where it intercepts the y-axis. And it's going to happen here at this point. Okay? More about that later. Then you have got the descriptive or vertex form. This one looks like this in general. Watch this. It has the square on top of the bracket plus k. This one gives us, what is it called? It's called vertex form, right? So what do you think it's going to give us? Yeah, the vertex. And here's where it gets a little tricky. The vertex is going to be whatever h is, whatever, like when you look at the equation or function, whatever h is, you're going to change the sign of h. And this is how we represent that in math. We put a negative in front of it. But k stays the same. Okay? And I'll show you more about that later. I don't want to go into details right now because too much information is also not good at the beginning. Factored form looks like this. For some reason, it's x and s, what most textbooks use. Sorry, I don't know why I did minus there. Should be plus. In general, it looks like that. And this one gives us the x-intercepts. Do you know what an x-intercept is? It's where the line crosses the x-axis. Okay? So there, in this case, there would be 2. It crosses it twice. So the first one would be, watch this. So it's kind of like, this is the pattern. If you take something out of a bracket, you're going to change the sign. So here, you go negative r, 0. And if there's a second x-intercept, then it'll be negative s, 0. I didn't mention that before to students, but yeah, if you take it out of a bracket, you change the sign, okay? So this is the nice part, okay? We're not factoring anymore, okay? You don't have to worry about that. Any of these, you can enter them into your calculator, wherever mine is here. You can enter them into, if you press y equals, you're going to be able to enter that into any of those and graph it and actually see it. So that's the nice thing, okay? I'm going to focus on the general form for now. Okay, so the general form gives you a bunch of things here. I would have all 3 of those on my study sheet actually. Let's go back and just highlight that. Just highlight that. So that means it's important. Obviously, you've realized that by now. A box highlighted, you know. So when you have a general form, we know the direction of the opening of the graph. And it is determined by the sign of the leading coefficient A. Okay, so if you notice that A is positive, you know it's going to open up. If you notice that leading coefficient is negative, you know it's going down. And I'm telling you this because it's important when you graph it that you should see that. If not, you made a mistake when you typed it in. Next, the width of the parabola. Okay? We look at the value. We simply look at the value of A, not the sign. So, there are 3 different widths we call. There's the normal one where A is simply equal to 1 or negative 1. It doesn't matter. if it's positive or negative, it's going to be the normal curve. So you're going to have something like this, so it just looks normal, or if A is equal to negative, it would look like this. Then you have a wider one. That's when A is between 0 and 1. Okay? A is between 0 and 1. So you have this, like make it really wide, like you're going to notice that the graph is going to do something like this. So it could be pointing up or down. That's based on the sign. And then the width itself has to do with the value. So example, if you have A is equal to 0.5 or negative 0.25, anything that's in between 0 and 1, forget the sign, just the value itself. Anything between 0 and 1 gives you a wide parabola. Narrow, if A is greater than 1, you have a narrow one, so you can actually make it very obvious that it's gonna like really become narrow and fold in like that. And it doesn't have to always be close to the y-axis. It could also be like this, off to the side, but it's narrow. Okay. Have that also on your study sheet. So I should put example, because sometimes students mix up the sign, like they look at the sign. So if A is equal to 2.5 or negative 3.5, it doesn't matter. If it's bigger than 1, like the number itself, it's going to be a narrower curve. Okay. Let's keep going. Then there's the y-intercept that's on the next page. And here's your first homework for tomorrow on this page. Okay. The y-intercept, a quadratic function will always have a y-intercept. You need to make sure you understand that a quadratic always has a y-intercept. It always crosses the y-axis. When the equation is in general form, the y-intercept will be 0, c. There's it one more time. Because it is a point on the y-axis. Watch this here. This is important. I'm going to give a different color. Okay. If the equation of a function has brackets on the right-hand side of the equal sign, it is not in general form. Okay. In that case, we need to use the calculator to find the y-intercept using second trace. X is equal to 2. Y is equal to, don't worry, oh, it's crooked. Don't worry about that just now. Okay, don't worry about this. I'll explain that more later. It'll make more sense later. Okay. I will do like 1 or 2 with you here, so you know what the pattern is. I give you a bunch of functions, right? I ask you opening, what the width is, and what the y-intercept is. Okay? What is the direction of the opening? Which way will this open up? You look at the sign. A is positive or negative? Negative. So this is going to be opening this way. You can call it the opening is down, or just say that it points down. I don't care. Whichever way you want to talk about it. What is the width? A is, in this case, greater than 1, right? It's greater than 1. It's 2, right? So this is going to be a narrow curve if you graph this. What is the y-intercept? Pause for a moment. What form is this? Is this general, or is it one of the other ones? This is general. It has no brackets, okay? No brackets. General, because it has no brackets. If something doesn't have brackets, you know it's in general form. So technically the y-intercept is back here, plus 0. Okay? So the y-intercept is 0, c. And what is c in this case? 0. So it's 0, 0. What is this point called on the Cartesian plane? It's called the origin, yes. Yeah. Next, is this in general form? No brackets, right? So it is in general form. Opening, A is justified every time. A is positive, so this one will be going up like that. What's the width? A is greater than 1. It's going to be narrow as well. And the y-intercept? 0, -2. I actually like you to state it as a point. I know that last year you may have written y-intercept is equal to -2, right? Like it almost looks like an equation. I don't want you to do that. I want you to stick with the actually writing it as a coordinate. So I want you to do the rest. Is this in general form? This? This? There's a bracket there, so this is not in general form. Okay? This is one of the other ones. Let me just stick with that right now. Not general. What is the problem with that? Let's do this one here. Which way is it opening? A is negative, so this will be down. Okay? What's the width? A is between 0 and 1, correct? So that's how we write it. So this is going to be a wide curve. This curve would open up a bit more to the sides. And what's the y-intercept? And you're going to say -3, and I'm going to say nope, it's not -3. Because this is not in general form. Okay? So what we have to do, this takes you back a little bit. What is x equal to at the y-intercept? I'm pointing at it. 0. So you will literally put a 0 in here. So you let x equal to 0. I'll do the work underneath, okay? Otherwise it gets a little cramped in there. X equal to 0. Y is equal to -0.91 times 0 plus 2 squared -3. I hope you follow this. That's hold off on the temptation to multiply this out, okay? Just first do whatever's inside the bracket. What is this going to get me? 2, right? What's 2 squared? 4. There you go, -3. And now you grab your calculator, okay? And you have to be careful how you type this in. This, if it's a number at the front, you go negative. You use this negative. So do that with me. Make sure you get that right. -0.91 times 4. That's -3.64 minus 3. So this is a minus, okay? When it's tacked on at the end like that, that's a minus. So we have to use this button right here. So I'm going to copy paste and then just go -3. So that gives you -6.64. What did you just find? You found that when x is equal to 0, the y value will be -6.64. Got it? Do you have to do this every time? Only if it's not in general form. Only if it's not in general form. How do you know it's not in general form? Brackets. There we go. Your smart cookies. So the rest, I'm going to leave that up to you. So I'll put at the bottom of this page, homework. How about this? You do these two while I give you a little bit of time. A couple minutes. You try these two here on your own right now. And then we'll continue, okay? This is that one. And this one right here. I may have tricked you a little bit, but the leading coefficient in this case is not at the front, right? It's not always like x squared x. It's not always, so you have to watch out. That is still our leading coefficient. Negative. Half is between 0 and 1, right? So it's wide, and it's 0, 0, because there is no constant visible. Okay, so it's that. I will post this so you don't have to This one? So again, when we look at the width, we only look at the value itself. So you want to kind of like just isolate to the value, and that is greater than 1. Yes. So for the opening, you just want to look at the sign. For whether it's narrow or not, you just want to look at the numerical value without any sign. That's a good question. Okay. Yeah. Because it's a good question as well. Because it's in front of the highest power. See how x squared? That is what determines what the leading coefficient is. Okay? Maybe this is the time to, maybe, because you're asking good questions actually. Okay? I like how you're questioning, is like, how is that greater than 1? How is that possible, right? We're just talking at the numerical value. So let me show you here. I think can you see that? I hope so. So look at A. This is A. This is my general form. So if I increase A, it makes the curve narrower, right? So the more I increase it, the narrower this thing is going to get. If I bring it down, right, it's getting wider and wider until it gets to, that's our normal curve, the 1. And then as you get between 0 and 1, it gets wider, right? Look at what happens when it's negative. We still say it's like wider if it's like 0.4, right? That's still between 0 and 1. But as soon as you get into the higher negatives, negative 1.5 or negative 3.2, it still becomes narrower. You know what I mean? So the narrow part, we just look at the actual value without the sign. The negative tells us if it's pointing down or up. Okay? All right. So I want you to try that. Let's keep going. Okay. I would love to graph at least one with you today yet. So if it seems like I'm rushing a little bit, I am to a certain degree. Is it recording or? Not sure. Yes, it is. Okay. So this is a very important point here, the vertex. Okay, very, very important. This is a must when graphing quadratics. The vertex has coordinates x and y, and watch this. How do you know that it's the vertex? Is where the parabola changes direction. So the vertex is where the parabola changes. It could be the highest point, right, the maximum, or it could also be the lowest point. Determine the coordinates of the vertex. We use this. Right now, you're not going to worry about that too much, but I do want you to highlight it, right, to determine the coordinates of the vertex. We use second trace min or second trace max. It depends on if it's pointing up or down. So watch this. Just sketch this with me. It should be symmetric, okay? A parabola is symmetric. What does that mean? That you can cut it in half, okay? Cut in half and both halves are exactly the same. You can fold it onto themselves, okay? Where is the vertex? It's right here. So you, always from left to right, you go down, but then it goes up. So this is what we call a vertex. And it will have x and y coordinates, of course. And in this case, it's a what? A max or a min? What would you be inclined to say? It's the minimum, right? The lowest, okay? So in this case, it's a minimum. And if it's pointing this way, the vertex is up here. And in this case, it's a maximum. Think about it. If you always read a graph from left to right. So if you're coming from the left, right, it is the highest point, and then it goes down. So it's the maximum. It's the highest it will ever reach, okay? The vertex provides us with two additional pieces of information. Watch this. Two different colors. I'm going to use green and orange. Let's do that. So it gives us the equation of axis of symmetry, which I call AOS. And it gives us the equation of the maximum and minimum. So the axis of symmetry is a vertical line that cuts through the parabola in identical halves and goes through the vertex. Okay. So for example, in here, visually, the axis of symmetry would be cutting through the vertex like this. And on this graph over here, can you see that? It's not perfect, but on this graph right here, the axis of symmetry would cut the parabola in half like that. It goes through the vertex, all right? And then both of them, so this is the axis of symmetry, cuts it in half. The equation of min and max, it depends. That's why I have maximum or minimum. That's a horizontal one. So in this case, what would this be, a max or a min? It's a max, right? Because it's the highest point of our parabola. And in this case, visually, it goes through like that. This is our min, okay? So, the problem is visually is one thing, but I need you to actually state what it is. The equation of this line would be x is equal to, what's the x value at the vertex 2, right? Let's go over to this one. This one would be called, the equation would be x is equal to negative 2.3, that's correct. This is an equation, right? Equation of this line. And then you've got both of the horizontal ones, they each get the y is equal to, y is equal to what at the vertex? It's 3, correct? What's y equal to at this one here? Negative 3.5. Axis of symmetry doesn't need a distinction, but these lines do need a distinction. In this case, this would be the equation of the max, and this would be the equation of the min. Okay. These are virtual lines, and I don't ask for them too often, to be honest, but you're supposed to know what they are. Next page. X-intercepts. Watch this. The x-intercepts, the quadratic can have up to 2 x-intercepts, so that's different than last year. Linear only has 1, but quadratics can have up to 2. Okay. Notice a pattern for applied grade 12. Watch this. The degree of the function tells you how many x-intercepts are possible. So if the degree is 3, how many x-intercepts do you think are possible? 3. Up to 3. It's not saying it's always for sure 3, but it can be up to 3. So here it is. You could have no x-intercepts, 1 x-intercept, or 2 x-intercepts. So that's the interesting part. I'll just show you visually right now. Maybe I'll use a red pen for this. No x-intercepts would just mean that the parabola does something like this. Right? It could go like that or like that. So either scenario just results in it never crossing the x-axis. 1 x-intercept is on, listen to this one, is when the vertex is sitting right on it. So it could go up like this, or you could have a scenario where the vertex is sitting right on it and it's going down. So make sure you have a big dot there saying that the vertex is on the x-axis. That's how you know there's only 1. And then you, of course, could have the scenario where you have 2. So in that case, you would actually cut through it there and then cut through it again there. So there's two x-intercepts there. Or you could have a scenario where it points up. You've got an x-intercept there or an x-intercept there. And these sections, I usually fill them in with some words and whatnot, but right now we're just going to say, hey, just recognize that there could be none, one, or two. Okay, so visually I just want you to be aware of that. And now, I'm going to use this bottom part. This is where we're going to use our graphing calculators, okay? I want you to grab your calculator. I want you to enter this equation here into, so what you need to press is y equals, and I think I need to make sure we're all on the same page here. Press y equals, and yours have been used before, right? So there could be stuff in these, so I want you to press clear, and then hit enter, make sure everything is cleared. Okay, next, plot, do you see plot 1, 2, and 3? We're not going to use it at first. So you should not have it highlighted. If it is highlighted, you go to it and just press enter. So let's say yours is highlighted right now. Go to it, press enter, and then go back down. It should be deselected. Let's type this into our calculator. And here I need you to make sure you press the right buttons. This one right here, you're not going to use minus, you're going to use negative. That button right there. That's your leading coefficient. So you go negative 9.85, and you're not going to press times for x, okay? You have this button right here. If you look up, my pencil's hovering over it. That is your x variable button. If you press it, you see x there. And then you press the x2 button to square it. Okay? Now any negative or minus afterwards, you actually use your minus button. So you go minus 15.05 x, so you gotta press that x button again, minus, so take away 3. Okay? And now I want you to press graph. And you may not see anything, and that's fine. Don't panic just yet. I'll show you what you do when that happens. The zoom functions are quite helpful. Let's all have the same window, okay? We're going to press zoom, and then we're going to go to zoom standard, which is the 6th option here. Everybody, I want you to go zoom, then zoom standard. Do you see something now? Yeah? Okay. Who's not seeing anything? Joe Mill? Okay. I hope you'll. Okay, just for fun, we're going to do the same thing. We're going to press y equals, and in y2, we're going to enter this one. See if you can do that, and then hit graph and see if you can see. If you're too shy to ask for help right now, ask me later, okay? I'm going to do that with you. I'm going to type this one in. So it's 4.75, and then you've got to use brackets. X minus 5, bracket, x2. Hit graph. Oh, there it shows up. So, okay, what does zoom 6, what did I do with zoom 6? Like, what was that all about? Let me introduce you to the window button. You're going to have to be very familiar with these buttons here. Press window. I want you to forget about everything else. The only thing I want you to think of right now is X-min, X-max, as well as Y-min, Y-max. Those are the only 4 I ever want you to touch. The other ones don't really matter. I'm gonna copy this with you. I normally don't do this, but I want you to know. If this is your window, copy this down. If this is your window, right? This bar right here, like how much you see to the right of your window, is governed by X max. Okay? So if you want to see more to the right, guess which value you're going to change on your window? X max. You're going to increase that. Which one do you think governs the left side? X min, right? So the left and the right are X min, X max. Okay? What do you think the top is going to be governed by? Y max, and this one is going to be governed by Y min. Okay? This is very important to understand. Why is so? If you're not having these parameters set to where they should be, listen carefully, the calculator graphs this thing, you're just not seeing it because your window, like your graph may be up here, but your window is set to such parameters that you're not even looking at it. Okay? That's why we're learning all about it before we graph. So what does zoom standard do? Let's mess around with the window here for a bit. Let's, like for example, X max, let's go 100 in there. And Y max, we're going to go 100 as well. So I'm changing X max and Y max. Hit graph. Whoa, what happened? You see that little blue here? So the graph is there, this is there too. You're just looking at it from a zoomed out perspective, like you're way up here somewhere, and you're seeing a bunch of stuff you don't want to see, right? This blank stuff here is pointless. Let's all go zoom, and we're going to go zoom standard. What happened? Yeah, we went back to a standard window. So press your window button. And what are they back to? That's the standard window. Okay? This one solves a lot of your problems because you're going to have to, listen carefully, you're going to have to change your window. Standard window won't always do it for you. Yeah. That affects a lot. So if you want to change this, you got to press. Which button do you think you're going to press between these two? You're going to press this one if you want a negative. Okay? So let's all do that. Negative 50. How about positive? Sure. Okay? You change them to negative 50, positive 50, hit graph. So you're just going to see more this way, right? Negative 50. So guess what? Where my pencil is right now, where do you think that is? That is x is equal to negative 50, right? And this is x is equal to 50. What about the top here? Y is equal to 10. We didn't change that, right? This is negative 10. So literally think of it that way. Okay? Let's do the zoom thing. So between zoom and window, you can do a lot of good stuff between the two. Okay? Let's say you mess up on your window. You type something in and boom, you lose everything. Everything just goes down the drain. Zoom standard resets it and then change it again until you start seeing what you want to see. Okay? One more zoom. So zoom is kind of like a tool. Window is like what's actually happening. Let's press zoom. The other one I want you to be familiar with is it's not even on your screen if you press zoom. Zoom fit. Zoom fit can sometimes help you. So either press 0 or you just go all the way down to zoom fit, hit enter. I don't even know what it's going to do now. It's sometimes unpredictable, but see what it tries to fit both of them in. Okay, is it perfect? Is it perfect? What do you think? I would like to change a little. I would like to see a little bit more here. What would be changed for this? Which parameter in particular? What should we do there? And I'm going to tell you there's no magic bullet for this one. You try it. So 30 or 100, we can try it, but I'm going to go 30 and then hit graph. So I went to 30 here, and then I see a little bit more. Okay? Question. Or I'm not going to ask you because you probably won't know right now. What you want to see every time, listen carefully to this one. You want to see your vertex, very much so. You want to see all the intercepts, like x-intercept, y-intercept. You want to see that. Okay? Is this crossing the x-axis, you think? Is it going under it? We're not sure. Let's assume we're not sure. You can actually zoom into that. Press zoom. And there's zoom in right here. Hit enter and watch what it does. You can actually go anywhere on the graph and investigate. So I want to zoom into that. Right? So you zoom in wherever you want to go. I'm going to zoom into that, and you can keep pressing enter and it will keep zooming in. It's very hard right now to tell. But if you want to zoom in, you can do that. And then you can use zoom again and zoom out and keep pressing enter, and it's going to zoom back out for you. As you keep pressing enter, it's going to zoom out. And so maybe sometimes that's going to help you out. Zoom in, zoom out. Zoom standard, zoom fit, right? So I've shown you 4 different zooms here. And you have to learn how to navigate those. Okay, guys? That's where practice is going to come in. I wish I could just give you know what? If this had been a touch screen, that would be so nice, right? We just like zoom in like that, but we can't. So you have to learn how to use it. I'm going to write down the zooms here for you. Zoom standard. That is actually option 6. Right? That's option 6. Standard window. It resets it. Resets it, okay? And then 0 is zoom fit. What it does is it tries to fit the curve. Okay? And then zoom in will simply, obviously, zoom in. I don't know what else to put there. Okay, just keep pressing enter and it'll just zoom in. Okay. Let's keep going. I want to get to the graphing, like actually you graphing. Okay. So I'm going to fast forward all the way. I'm going to skip a bunch of pages. We're not going to talk about domain and range today. I'm going to do that tomorrow. I know you should have talked about it last year. Do you remember your domain and range? Well, I'm here to revisit that a little bit. Go to page 9. Go to page 9. Before I start, okay guys, this calculator is extremely accurate. So sometimes it's going to try to give you something like this. Watch this. When you see that E, that is saying exponent, all right? So I don't want you to read this and say, oh, the answer is 5.71. If you see e to the negative anything, the answer is 0, okay? Like for us, we don't have those significant figures in this course. Like we don't go to like 6 decimal places. We just call that 0, okay? This, if you see that, we'll just say that it's 0. Because technically what that is saying, it's saying times 10 to the negative 7. That's the calculator way of saying that that's what that is. We're just going to say that's 0. We're not going to bother with that. Okay, that's first disclaimer, because that happens a lot. And before you graph, I want you to answer these questions, I think up to here, for sure. The first 3 for sure. What form is this in? It's general, right? Basically, I just want you to know this is general. Okay, that's I want you to know that. So that's general. No brackets. Which way is it opening? So it's opening. We expect this thing to do this, right? Because let me tell you, these numbers, the numbers that you're going to see here get big. Okay, so I want you to know this so you can anticipate the behavior of the curve. The width. A is between 0 and 1, right? It's 0.5, correct? So this is going to be a wide curve. So it's going to be doing, instead of just saying this pointing down, it's actually going to be doing something like this, right? That's kind of what we expect more likely. All right, let's type this into our calculator. So,
please excuse the interruption. This is just a reminder that Hope would like to know.
Anyways, I type that in. Negative 0.5 x squared. Make sure you do this because I want you to try it already. 25x minus 200. Question. In this particular case, could we have answered the y-intercept without plugging in 0 into x? Yes, because this is in general form, so technically we know that the y-intercept is negative 200. So we're going to say this before I type. So this one is often, if it's in general form, you can answer this one too without graphing. So let's graph this thing. Can you see it? You can't? Okay, that's good. I actually wanted that to happen. So mean, right? What would you do? So I'm guessing you're all seeing this. Did you see a little bit? If you do a standard, let's do a zoom standard, everybody. Zoom standard. Go zoom 6. You should see a little bit of it here, right? What do you think? What is this of the whole parabola? Is this the left leg or the right leg? Which way are parabolas doing this? Right? So this is the left leg. It's this part right here. Just coming by here. Let's try a zoom fit. Let's see if that helps us. Press zoom. It may or may not help. This is the frustrating part. Zoom fit behaves differently every time. Okay? Oh, does that help? No. But it's better, right? We see this. We have our y-intercept right there. What should we change here for this particular case? Window. I'm going to go back to graph, sorry. Graph. I'm going to change the x max for now. Okay? I want to see more. I want to see the entire, it coming back down. So I'm going to go window. You try it. Give it a few seconds. Try changing your window till you see more. I want you to just try thinking of it. If it doesn't go well, don't worry about it. Should you go by 10s? Should you go by 20s, by 50s, by 100s? How much should you change it at a time? That's up to you. I tend to kind of focus on the scenario a little bit, so I'm going to try 30. Let's see if that does it for me. Not at all, right? So I'm going to now I'm getting frustrated, so now I'm going to go 200 for my X max. Don't change too many things at the same time. 200, see that? 200, and I have some room to spare. So watch this. If this is 200, look up here, right? If this is 200 to here, then this is about 100 right here, correct? So I'm going to go back to my window and just say, you know what, 100 is good. And let's see if that works. Much better. Okay, so I've got my X min, X max figured out, correct? What should I change now? I don't care about, like, down here, I'm good. Up here, right? So what are we going to change? Y max. We're going to change that to, I'm not sure, I'm going to go 50. Oh, I need more. So I'm going to go back to my window. I'm going to go 150 now. I'm getting frustrated, right? I don't want to waste too much time. And there we go. Is your graph going to look different than mine on a quiz or than your neighbor? Yes. But you're looking at the same curve, guys. Okay, don't make that assumption that yours looks a little wonky. Maybe you did use 200 for your X max. Oh my goodness, mine looks different. You're looking at the same curve. You're just at a different spot, okay? So don't let that throw you off. As soon as you see the whole curve like that, you're golden, okay? You're good to go. You can do the rest of this. Okay, I wanted to do a little bit more, but I'm going to stop here. So your homework is page, was it 6? No, 5, right? Or 4. Bingo. Finally got it. So 4 and hold on. I want you to try to graph pages 9 to 11 on your calculator. Okay? So graph pages, you already did 9. Okay? You did 9, but how about this? 9 to 11. How about you clear whatever was on your screen, go zoom standard, and then try to replicate what we just did. So I don't need you to actually fill in these boxes. I just want you to, on your calculator, be able to see this. And this is how you're going to prove that you did it. You're listening, right? You're going to do this. For example, my window for this particular example here was this: -10, 100, -500, 150. Okay? X min, X max. So I'm reading it out in that order. Y min, Y max. So X min, X max, Y min, Y max. So I'm expecting to see something on 9, 10, and 11. 10 and 11 only for you, right? Because I already did 9 with you. But that's how I'm going to be able to tell whether or not you actually tried it. Let me just tell you this, okay? This is going to be the most frustrating part of this entire unit. Being able to type in the equation, graph it, and then actually find a window that works for you, okay? That's why I'm doing this. And then tomorrow we'll fill in the rest of the boxes because we got to use our calculator to find all the intercepts and the vertex and all that. It actually gets fun once you know how to use it. Thank you guys. It was a long lesson.